Hi, everyone. We're going to continue working with our compound interest formula that we talked about in class yesterday. And so remember, our compound interest formula is a special case of exponential growth. And here it goes. And let's define everything again. There's lots of variables here to define. So A is the final amount of our investment. P is the principal. It's our initial investment. And notice in the parentheses here, okay, the addition sign tells us that something is growing. Obviously, if interest is being compounded, our money is growing. All right, so let's talk about what everything represents here. R is our rate. And remember, that's always a decimal. So we're going to convert the rate to a decimal. R gets divided by N. And N represents the number of times that interest is compounded during the year. So N represents the number of times interest is applied or compounded in a year. And notice N appears twice in the compound interest formula. It also appears in the exponent. The exponent is made up of two things, the N and T is time in years. Okay, so when we're looking at these compound interest problems, we want to make sure that in the context of the problem that we're identifying our N properly. And so again, if we're told that interest is being compounded annually, that means N is 1. Quarterly means that N is 4. Daily, that's 365. If interest is being compounded semi-annually, that's twice a year. Monthly is 12, and weekly is 52. Okay, we're going to do two things. First of all, we're going to just read all this information and make sure we can set this up properly. And then we're going to go back and make sure that we can input everything into the calculator and get the correct result. All right, so we have $1,000 invested at 6%, earning 6%, we should say, compounded quarterly. How much will we have after 5 years? So our principal here is 1,000. Our rate, and we're going to convert that into a decimal, is 6%. Compounded quarterly means that our N is 4, and then our time frame here is 5 years. So let's go ahead and set this up. We're looking for the final amount. We have a $1,000 investment, 1 plus. Our rate as a decimal is 0.06. Now, going back to our formula, we're dividing. Well, let me scooch this up. I apologize for that. We're taking the rate and we're dividing it by N, and N was 4. And we're raising that. Notice our exponent is made up of N and T. So our exponent is 4 times 5, or 20. I'm going to clean this up before we throw this in the calculator. So A is equal to 1,000. We've got 1 plus. We're going to put this 0.06 divided by 4 in its own set of parentheses and close both sets of parentheses, and we're going to raise that to the 20th power. Okay, that's for the setup. Let's set up 2 and 3, and then we're going to go back and do the calculation with our calculator as well. Okay, so example number 2, we have $2,000, so that's our principal. This is also earning 6%, compounded weekly, so that's our N value, and we want to know how much we have after 7 years. So for our setup here, the final amount, we're investing $2,000. 1 plus, our rate remains 0.06 weekly, so we're going to divide that by 52. Let me put that in its own set of parentheses, and then we're going to raise that to the N times T. We're just following our formula there, so that's 52. That's our N value times 7. Okay, let's clean this up. So A equals 2,000 times 1 plus. I've got this 0.06 divided by 52. I'm not even going to get a decimal for that. I can throw that all into the calculator at the same time. We do want to multiply 52 times 7. clean up that exponent, so that's 364. And then again, we'll do the final calculation in a minute. Okay, last example here. We have $1,500. .08 divided by 12 for monthly. And we're raising that to the n, which is 12 times 9. All right, and so let's clean this up. So A is equal to, got $1,500 divided by 12, that's our rate. And then we're gonna raise that 12 times 9, that's 108. All right, that's the first order of business, making sure that we can set everything up properly. Our second order of business is to make sure that we're going to input this properly into our calculator. So let's go back to number 1. Let's get the glare out. Okay, and let's make sure we can get a good final result here. All right, so I've got $1,000. I'm going to open up a set of parentheses. I've got 1 plus, and I'm going to open up a second set of parentheses. And so it's 0.06 divided by 4. I'm going to close that parentheses, and then the outer one as well. And I'm going to raise that to the 20th power. And so $1,000 then, the final amount, $1,346. We're going to round this to the hundreds because we're talking about money, and 86 cents. Okay, let's look at that second example. We've got $2,000 in this case. 1 plus. I'm going to open up my set of parentheses and take 0.06 and divide it by 52. Close both those parentheses, and we're going to raise that to the 364th power. So again, how much is $2,000? After 7 years, when the interest is compounded weekly, it looks like the final amount then is $3,043, and we're going to go 19 cents on that. And last one. $1,500, 1 plus, 0.08 divided by 12 for monthly in this case, and we're going to raise that to the 108 power. These are all reasonable answers. Okay, money should be growing here, but we shouldn't end up with, hundreds of thousands of dollars. It doesn't make sense. We're not investing that much to begin with, and we are not earning a crazy amount of interest. Okay, we're going to call that 30 cents. Okay, that's our compound interest formula. Remember, our compound interest formula is just a very specific case of exponential growth. Exponential growth, and the reason we know it's exponential growth is because of that. Okay, the second page is for you to complete, 4, 5, and I don't know what happened to 6. Well, let's do 4, 5, and 7, kiddos, and then I will post answers for this, and you can compare and make sure you're on track with this. All right, we'll see you Thursday. Bye now.